Now, when we talk about the dynamic path, so in the dynamic path, there are a couple things that plays a role. There is an optimization objective and there are some constraints. Based on that, it will go ahead and calculate a path, and that path will be consumed by the policy. A dynamic path express an optimization objective. So we need to have some kind of an optimization objective. So optimization objective, hey, like I want to traverse the link which has more bandwidth. I want to traverse over the link where we have lowest latency. I want to traverse over the link which has the lowest number of routers or the hop it needs to cross. So those are some of set of your constraint or the optimization objective. As well as we can go ahead and give some kind of constraint. Okay, when I'm traversing over certain path, I want to make sure that path has at least 1 gig of bandwidth. When there is a set of policy between a set of pair, I want to make sure if I have more than one policy, both of the policies are using a unique path. That way, if one of the path goes down, I still have a path using the different path. So these are some of the constraints that we can go ahead and configure. The head end, simply the node where we are configuring the policy, is called again head end node. It computes a solution to the optimization problem as a SID list or a set of SID lists primarily. When the head end does not have enough topological information, the head end may delegate the computation to a PCE. And we'll talk about what is PCE a little later on, so you can just skip that for the time being. But whenever the network situation changes, the path is recomputed. That means, let's say if I go back quickly to this particular example, let's say our policy had decided to pick the stop path from 1 to 2 to 2 to 3 to 4. But for some reason, let's say this link go down between 2 and 3. That means this path is no more valid. So the head end needs to find an alternate path. That means it will go ahead and calculate another best available path. And it can potentially go ahead and take this bottom path. So that's what it says here, that whenever the network situation changes, the path gets recomputed. Now let's quickly talk about an explicit path. As the name kind of really says, hey, explicitly, where you as an end user configuring explicitly and telling, okay, hey, I want this policy to follow this specific path, no exception. So in that case, an explicit path is an explicitly specifying SID list or a set of SID lists. So that means when you configure a path, you will go ahead and different SID list and you can associate a weight. And once that path is configured, you can go ahead and associate that path with your SR policy. This is explicit, as simple as that. That means you have dictated, okay, I want my policy to take this path. So there is a drawback with this. Let's say the link between SID 11 and SID 12 goes down. That means this policy or this path becomes invalid. And because in explicit path, in this case, there is no recomputation is going to happen, because as an end user, we had configured this as an explicit path. That's why we have multiple paths. In case this goes down, the system can go ahead and pick this path. But let's say even this path happens to fail. That means the whole policy will probably go down and there is no automatic computation or recalculation. So now you would ask a question, then why would somebody will use an explicit path? Yeah, this is again depending on the situation. If you don't want any kind of routing protocol to be involved, no complex calculation, and you are okay to have your policy updating manually, yes, you can go ahead and do that. But most of the time, in majority of the deployment, you would see people trying to use the dynamic paths. So with that, let's go ahead and proceed further. So we saw that these are different candidate paths. Now a candidate path has something called a preference. That means when we are configuring multiple paths, we can give a preference to our paths. A candidate path is associated with a single binding SID. There is a binding SID also. Again, we'll go ahead and take a look at example. A candidate path is valid if it is usable. That means in this policy, I'm giving multiple paths. The candidate path is valid if it is usable. That means if for some reason, let's say the node that you gave is not reachable, that means that is not a usable path and that is not a valid path basically, or not a valid candidate path. Okay, and we'll go ahead and take a look at the example. So within the candidate path, we saw we can go ahead and configure multiple SID lists and we can also assign a weight to them. Candidate path. A head end may be informed about candidate path for an SR policy. That means color endpoint by various means. So that information can come from CLI. That means you're configuring manually using netconf tool like an SDN controller, or you are getting that information from the BGP updates, or you are getting that through the PSAP protocol. In the PSAP protocol, we are using SR-PCE. And again, we'll go ahead and take a look at some of these things.
Now within SR policy, there is something this as path selection. A path is selected for an SR policy when the path is a valid. So the policy needs to make sure the path that is being assigned is a valid path, and if it's not valid, it will not go ahead and pick that path. And its preference is the best, means highest value. Higher the preference, the better the path, basically, among all the candidate path of the SR policy. The protocol source of the path does not matter in the path selection logic simply. Okay. So that's what it says. Path source does not influence the selection. So in this case, we have an SR policy. There is a head and color and endpoint where we have multiple candidate path. There is CPath 1, CPath 2, CPath 3. And it say here the preference is 110, preference is 100, preference 200. And as we just saw, higher the preference, better the path. So in this case, it will go ahead and pick this path, and it will go ahead and pick this SID list. And again, these paths can be provided by different means. In this case, this is provided with the help of BGP-SRT. Selection of a new preferred path. Whenever a new candidate path is learned, or the validity of an existing C path change, or an existing C path is changed. That means if your current candidate path goes down, or even if we have a new better candidate path available, the selection will re-happen and the policy will go ahead and pick the new path. That's what it says here, that for some reason this path becomes invalid. The policy will go ahead and pick the next best and preferred path. In this case, it will switch to 110. This we kind of know, segment ID. I'm just going to skip through this one. Now, what it says, there is something called invalid SID list. That means it's simply a SID list is invalid as soon as it is empty. That means if there is no labels, there is no IP address, that means that SID list is just simply empty. The head end is unable to resolve the first SID. That means it cannot resolve the first SID. That will also become an invalid. And these are some of the other properties that you can read through. Same thing happens if you are using those invalid, the path will go down simply. And an invalid SR policy, an SR policy is invalid when all its candidate paths are simply invalid. That means we don't have any path to reach our endpoint simply. These are some of the behavior that it talks about what happens when the policy becomes invalid. This is an example of the SID list. Now let's talk about the binding SID or B SID of an SR policy. The B SID or binding SID of an SR policy is the B SID of the selected path. So whatever is the path that is being selected, for that path, SR will go ahead and assign a SID, and that SID is called as your binding SID. That means the system can reference the whole path with the help of one single SID, and that SID is your binding SID. Don't worry if it's not making sense. We will go ahead and explore in the hands-on this binding SID. And that's what it says. An SR policy should have a stable B SID. That means in all the use cases known to date, all the candidate paths associated with the given SR policy have the same base SID. Okay. One may thus assume that in practice, a policy has a stable B SID. That means the policy has a stable B SID, and you can use those B SID in some other policies if you desire for some reason. And we'll go ahead and explore during the hands-on. An active SR policy, simply an SR policy is active at a head end as soon as this head end knows about a validate candidate path. That means when you have a good and available and valid candidate path, the policy will come to an active state. An active SR policy installs again a B SID entry into the forwarding table with the action of steering the packets, whoever are matching with this particular SID list. Now that's what the example it says, okay, hey, this is our policy where we have a selected path, and in that path, these are the different SIDs it's going to go through. Now in the forwarding table, that's what it says, okay, hey, this is the B SID that is being installed. And with that B SID, these are the nodes that are being associated, and it talks about, okay, which is the interface. Again, it can use the weighted ECMP, so it can go ahead and use the multiple paths. It talks about the SR fib entry. Again, we'll go ahead and see all these things during the hands-on, so I'm going to go ahead and skip through.